Good morning, everyone. Today I want to talk about the torso and the shoulder assemblies. The torso will go real quick. It'll take a little bit longer to talk about the shoulder assemblies. So with that, let's get started. I'm going to shrink myself down like I usually do. Stick myself down here in the corner out of the way. And I'm going to start up my robot lab from a command prompt. And I'm going to use my little bat file, startup bat file that I created. So you can copy that if you want. I go a little bit more detail on that in my bicep video, so you can learn more about it if you're interested when you get to the biceps. While everything's loaded, I'm going to go right here, right click on Start Menu, go to Device Manager, go to Ports, and see I'm using COM port 4. So here I'll go to Intro, go to the fingerprint. I consider this to be more or less the home screen for the robot system. And from here I'm going to start all my services. You may hear the robot talk in the background. And we'll give everything a second to start up.
Starting mouth. Set language back to English. Chapter loaded. I may start other components. Please wait. Starting is. Starting head. Starting mouth control. Starting left arm. Starting left hand. Starting right arm. Starting right hand. Starting torso. Startup sequence completed.
Okay, everything's complete. You can see all my services are now listed over here on the left hand side. So just for my convenience, I'm going to kill the ears so that he's not listening to me and tries to talk to me. I'll just kill the mouth as well. So all that's stopped out of the way. Now I don't have any background annoyances while I'm recording all this. Now I'll go to controls, control settings, and I'll demonstrate the left shoulder. So I'll start the left controller. These screens can take a few seconds to load, and should fill in my board type here. Yeah, okay, I'll do it. There it is. Uno board is what I'm using. I'm on COM port 4. I use the default communications rate, and I'll connect to my Uno board. And I get my green light. I now have a controller. And I'll scroll down my services to my left arm. And under the left arm, I'm interested in the Omniplate and the left shoulder. So the Omniplate, attach it to the left controller, and that's pin 11. I'm using, instead of pin 11, I'm using pin 3, just temporarily. It's for my convenience. And I attach that. Now I'm just going to let it sit here for a minute, and actually, well, I'll come back to it. I'm going to let that sit here for a minute, and I'm going to show you some still pictures of what I've been doing explain what's happening. Again, my cameras are very limited, so what I show you real time is going to be limited. I'll use a lot of still pictures. Let's start out here with the torso. Blow it up a little bit bigger. The torso is not complicated, guys. It's all it is a print a bunch of parts, snap them together. That's all there is to the torso. There is a front, there is a back. This guy's done us a great favor. He's laid out all the pieces, and he's put their names on them so that, as you can see, it makes it easy to identify which piece goes where. The only maybe hidden feature here is that these three pieces have to be printed twice. They need to go down this row, and they need to go down this row, and then they snap, the front and the back snap together, and this acts like a spacer between them. So I've got this built and assembled, and I did it without gluing anything because of just lack of confidence maybe, but it's in the test mode, so why glue it? So I've got it all assembled, but my plans are that I will go to each one of these joints, and I'll use my thermal pen, and I'll weld these joints together. Now I'm not going to go all the way around and up and down all the joints. I'll tack weld it in places just so that it stays in place and I'm comfortable with it. The one area that I've discovered that I'm not going to do any gluing on is this piece right here. And this is really for the neck, not for the shoulders. But if you ever need to service that servo for the neck, these pieces are going to have to be removable so that you can get in there. So I'll tack weld the back pieces together. I'll tack weld the front pieces together. These two assemblies, I'll probably tack weld this right here so that it stays together. Again, I'm not going to tack weld here because this piece is removable for servicing a servo. Set those in place and sandwich the whole unit together. I haven't quite made up my mind if on one side and one side only I might tack weld where these pass through so that it's at least solid on one side. Now, the reason I'm not doing it on both sides is if I ever need to make a repair, I'm going to design mine so that my front pops off and I can get internal to everything. And I'm choosing the front because it appears that everything's being mounted on the back. So why disturb all that? I'll just pop the front off if I need to make a repair or a change in the future. So with that being said, that's probably all you're hearing me say about the torso. There's no components other than that. Of course, one last thing, you'll have to draw out your hole sizes as you use them to make sure they all fit. Fit and finishes a file. Okay, so be prepared. Now we'll move on and we'll get into the interesting part. We'll talk more about the shoulder assembly. And I start out by showing you this basic picture of the shoulder and the arm. They're so related they even put them in one picture. And I want to talk a little bit about this area up here to begin with. On the pivot house, this is going to be the first area that we do the electrical alignment on. I'm not going to go through, the nuts and the bolts, how I put it all together. In my bicep, I give you references to two really good YouTube channels. Those guys have got the cameras. They show you how it's done. So I'm not going to bore you with my attempt with no cameras. But once assembled, there's a couple of areas of interest for the electrical. Here on the pivot gear, you see this little like peninsula sticking out here into the hole. When you put the faceplate on and you add this potentiometer square assembly, this horizontal hole is visible through this hole. That's for your electrical alignment. That's going to be kind of your zero reference point. So I point it out here because it's so much easier to see than it is on the assembly. That's the key, the secret. So when you put this together, you can either rotate your worm gear and get that alignment close. That's what I would do and did, and just kind of leave it aligned at least close to that zero reference to make your final adjustments much easier. We may come back to this to discuss other areas, in this area in particular over here. Here's a blow up of the shoulder, pieces by name, just kind of help you see where it all fits together. And here's an exploded view. Now, the exploded view, the gear is inserted here into the housing. So you can't see that peninsula sticking out that I was showing you. And over here on the plate that attaches, they have not inserted the little potentiometer pieces. So that's why I kind of point them out to you back here, right here and here, okay? Because they're not shown well in other drawings. And I wanted you to see that relationship. Here is basically why everybody came to look at this video. I want to show you a video of my pivot in action. Now I limited the amount of motion for one reason and one reason only, and that's because you can see I got cables hanging here. It's all temped in, and if I try to wrap this thing around too much, I'm going to pull my cables free. So I limit my motion. But you can see I've got it here on spin, and everything worked great. Good final product. Now here's the Omniplate in action. And if you look up here, you can catch a quick little glimpse of the piston gear going up and down, lifting the whole shoulder assembly. And that works like a champ. And maybe to show off a little bit, here's both of them running at the same time. So you can see the pivot rotating this direction, and you can see the Omniplate being pulled in and being pushed out. Everything's running smooth. So that's the final assembly, guys. Everything worked. I was happy. My right shoulder looks just the same. Here's what the back of my robot looks like right now. The back of my torso. There's a few extra components on here that I'll just mention why they're there. These servos, these 3 servos, and this little component area right here, they're all for the neck. But they go inside the torso. So I've got shoulders that go inside this torso. So I'm not going to put this together and tear it apart, put it together and tear it apart. And I just took time to build enough of the components for the neck that need to be mounted internally. And I put them all in so I can put this torso together once, leave it together. Now, with it in this position, now I'm free to be able to go in here and tack weld all these parts as my testing goes forward. I will wait probably and tack weld this when I've done a little bit more on this neck to make sure everything's aligned. This is a little bit, this picture is a after the fact picture, let me put it that way. I needed a picture to demonstrate something for you, but I didn't take it before the assembly. So you can see here, this is the pivot assembly already mounted into the torso. But I've used the Omniplate and pulled it out where you could see the bottom edge. And the reason I've done that is I want to demonstrate to you what I used as a zero reference point during my electrical alignment. This is the housing of the pivot assembly, and this is the plate that rotates. And here's where the two meet. And what I did here, I used this edge right here as my zero alignment. Yeah, I was showing you earlier the peninsula and the potentiometer plate and the hole. Well, you can't see all that during the electrical alignment. So I picked another point as a reference point. So as we move forward, just remember this is the area I'm talking about. Here is before I mounted anything into the shoulder. I had the whole shoulder assembly just sitting on the bench. But I've removed the Omniplate piston gear so that I have access to the potentiometer for the pivot plate. Here you see I've got it mounted in, and here I'll show you how I did that electrical alignment. So we'll go back here to the left shoulder, and I'll pick that up on the left controller, and that's on pin 4. And the limits, I'm going to lower the limits down to about 120 to be something realistic. The minimum set at 0, which is good because I want to do a 0 alignment. Okay, and the rest position's at 30. I'll just leave it there for the minute. Now, what I did when I did this controller, I went to the advanced, the auto disable feature. This is the feature that removes power from the servo so many seconds after it's achieved its position, to probably more than likely to conserve battery power, but it can also be seen a little bit as a safety in case you're binding. Power is removed probably faster than you can react. But I don't want that right now, so I'm going to disable that feature. I'll go back to my controller because, yeah, I have to do the attachment. Okay, now I have an attachment. I'll go to my basic screen. Let me pop this back up now. Now, I turned my speed way down so that it was moving real slow, because I'm not a young whippersnapper anymore, and my reflexes aren't as great. So with that set like that, when I move my slider down to 0, my servo motor is going to continuously run trying to get to 0. And it's never going to time out on me on the auto stop feature. It'll hit 0 and run past 0 and back and forth, right? Very slowly, so that I have reaction time. Now I'm going to take my finger and I'm going to go down the side of that housing over here, right? The side of the housing. And this plate is what's going to be rotating back and forth. And I'm going to run my finger back here, and I'm going to feel for when that plate is even with the edge of the housing. And I'm going to do that as I'm rotating my potentiometer. So when I fire it up, I'll let it come. It'll go to some position, right, wherever that potentiometer is, and stop. Now, it shouldn't be too far off, because the horizontal hole in that peninsula plate and the horizontal pin of the potentiometer are going to line that up somewhere close to 0. Then you're going to rotate that assembly until you feel those edges aligned, right? So I would slide this down to 0. Like that, to do that alignment. Once I'm there, then I would stop. I would hold it, of course, and I would disable. I would disable my servo motor so that it stopped. That way I don't have to worry too much about it. Then I'd go in and I'd tighten down that placement screw. This one right here. That prevents this from moving. Before I did that, I didn't show it in this picture. Another thing you could do is you could put a little felt tip marker right here, so that if things are moving as you're doing this, you could mechanically get that back in alignment and hold it there while you're tightening that screw down. And then test it again, right? Bring it up, go through the My Robot Lab, go to basic, right? Move that off 0, move it back, right? Test it and see how happy you are with that alignment. Did that edge come back where you wanted it? That's how I aligned the pivot plate. I put the gear back on, mounted it all back on, and then I mounted that whole shoulder into the torso. Once into the torso, the fun begins. This is all custom. There's no standards, no nothing here. This is by the seat of your pants, but I guess, and by golly, what works for you. Gail suggests using tie wraps to kind of hold these cables. And if you go to his page and follow his tutorial, he gives you some basic guidelines. I would again start with his tutorial and then go to the YouTube videos and then maybe visit mine for the final alignment. But you're going to have to fold these cables. Remember, all of these cables have to slide inside of the torso in a gap right in through here. They all have to slide in through here. So they have to be held up pretty tight. Now, for me, the tie wrap I call it kind of my last line of defense. It'll hold the cables somewhat in place, but there was so much sag and drop and droop that there was going to be no consistency with the movement of those cables. So I got out my trusty hot glue gun and I hot glued the first cable to the housing, and then I hot glued the second cable to the top of the first ribbon cable, and then I routed the potentiometer down this side, the power cable down this side for the pivot plate. And then over here, this is the holster, the servo holster, and the servo for the Omniplate piston gear. Now, the Omniplate, the power cable right here has to be routed through this gap, and the potentiometer has to be routed to this gap. The potentiometer for the pivot plate does not have to go through that gap. We'll see that a little clearer in the next slide. Right here, let me blow that up. I got my potentiometers backwards. The potentiometer for the piston gets routed around that gap. The potentiometer for the Omniplate has to be routed through that gap. So this is the gap between the pivot plate housing and the holster assembly. Very narrow gap. Let's see the next picture. I think I show the gap a little bit better. There it is, an up close, uptight picture. You can see there's a narrow gap down through here. So you have to play with your cables and get them to lay in next to each other. The two ribbon cables can pass through one on top of the other, but the others you got to kind of make sure you lay them in next to each other so that they make that gap. Play with it a little bit, it'll take a while. The result is I have two ribbon cables and two power cables routed out to the face of my shoulder, out towards where the arm's going to mount. Here's the back side of the pivot assembly servo motor. So the ribbon cables are coming from this side over here. They're tie wrapped and hot glued along this side. This is where they drop to the back, out to the back, to be attached to the servo board. And here's the routing for the Omniplate piston. So you can see that's the one that doesn't have to go through the gap. It comes up and around. It doesn't go through that gap. So you can see the assembly here. The Omniplate assembly here was on the right hand side, didn't fit well. You can see I had to elongate the holes on this plate to get the horizontal gap in the center of the piston assembly. I mean, of the potentiometer assembly. It was just off to one side, so I had to elongate it so that I could move it over and get it centered. And down here you can see I even had to file a little bit off right down here so that I didn't have any interference with the travel of the plate. So once I got all that assembled, then I could drop the potentiometer in, kind of screw, I screwed it in place on here, of course, first, dropped it down in, put my screw in. Now, I don't know about you guys, but I've discovered there's 1,000 million different screws on this thing. You can go bankrupt just buying screws. So I used screws that I had on hand. These are little 4mm long wood screws, but they're countersunk heads, so they didn't sit well here, and I just threw a couple of washers under them so that they would, go over the gap and lay where they needed to lay, and I screwed them down tight. It worked. I'll be honest with you, I was never comfortable with using the screws to begin with, but I did. I put them in. I gave them a shot here. So everything's in place. This is loose. And the next thing I did was for my comfort level, I went in and I manually grabbed that piston gear and I ran that Omniplate out to about halfway so that when I powered this thing up, it would either move in or move out and give me a little reaction time if I didn't like what I was seeing. So I did that. And again, I came over here. I went to the Omniplate, left shoulder, pin 3. I attached it. I went to advanced. I turned off the auto disable feature. I went to limits. I adjusted the limits down to comfortable levels for me. I adjusted the minimum down to 0. I went back to basic. Well, I went to controller and I enabled it. That's when things took off. Okay, and they got steady. They settled down. Oh, again, I would go back here to the basics and I would take that speed way down to give you that reaction time. Once I did that, then under basic, I moved it down to 0. I crept it in. I didn't just slide it down. I crept it in so that I could watch where it was going. When I got to 0, of course, things weren't perfectly aligned. But as I was going to 0, I could hear it and feel it. I could see it shake and clunk. So I knew I was getting a mechanical bind. I was hitting something somewhere. And so when I looked inside the torso, and you can see the back of the servo holster and the back end of the servo. My servo was traveling up and hitting the top edge here. when I went all the way to 0. So I needed to prevent that. So I played with my 0 setting here, and the way I did it, to get a little precision and a little bit of control, because sliding that slide bar, you know, if you got a trimmer like me, it's not going where you want it to go. So what I did was I went into limits and I adjusted my reset, and I just took my reset point down. Oh, I started out I think at 3. Then I went back to my basic screen and I hit the reset button. And that servo moved off of 0 out 3 degrees. And I looked to see what kind of reaction I had back here. And I just kept playing with that reset. I think I ended up being able to take it into 2 degrees before I got too close to that top edge. So now I knew my lower limit. So with that said, I can now come back here. I could take my reset point back up out of the way, somewhere up in here out of the way, and I could take my minimum and I could set it to 2 degrees. Then I could take my slider bar, I can move it out, and I can move it down to 2 degrees. See how it looked, how vertical it looked, and how clear I was back here. And for me, everything looked good. I looked pretty good vertically on the Omniplate, so the shoulder looked like it was, hanging straight down. Pretty good. And I wasn't getting this mechanical bind back here. That's the way I handled that problem. I think that worked pretty good. And again, I did turn off that auto disable feature because I needed to be able to move this potentiometer until I got it where I wanted it, right? And once I got it where I wanted it, you can see here you can see where I marked this one. I powered it, disabled my servo motor, tightened everything down, tightened down the lock screw. Well, on this one, see, I didn't even use the lock screw because I just didn't like them. I used my hot glue gun, and you can see here's the edge of the potentiometer insert, and here's the housing, and I just laid a bead of glue over that. And while I was there, just for my sake and comfort level, I dropped a bead of glue around this screw head here, and it kind of filled in that elongated hole a little bit. And to double check it, I laid a bead of glue along the edge of the servo motor. Everything's locked in and it's tight. With everything locked in and tight, then I could go back and play, enable my encoder again and go back and play with my basics like I was showing you. Run it in and out. Everything looked good. I was happy with it. So the alignments weren't bad. The worst part was routing all those cables. And for me, my biggest worry was, what if I didn't get the cables long enough to go down into the bicep, and connect? What if I left too much up on the other end? And I know a lot of that comes from my background. I was in an installation battalion in the Army, and we ran 150 foot, 200 foot, 300 foot cables. 26 conductor cables and stuff. And when you pulled all that through the ductwork and got it up there and found out you were 2 feet short. 120-foot cable that's $10 a foot is a lot of wasted money. So we always use the standard. You measured it to fit and you added 5 to 10 feet, depending on the difficulty, right, to the length. It was a lot cheaper to throw away 3 feet because your measurement was off by 2 feet than it was to throw away 120 feet. So I'm sure that's where all my worries come from. But I know for my own comfort level from now on, I'm not going to do that. I'm going to use extra long cables just so I'm comfortable. Enough said on that. Now I want to talk a little bit about how I'm going to do the electrical connections. There's no place where he says mount these mini assembly boards at a specific location. You put them where you want them. You put them where they fit. You know, it seems to all be custom at that point. So I want to talk about how I'm going to do it because it's just my way. Now the hand, I'm not going to talk too much about right now. You can see there's 5 pins for each finger and a 7th pin for the wrist assembly. So you're going to tie the 5 fingers and the wrist will tie in here on the hand, and the arm is the one I need to talk to you about right now. It has 4 pins. Right, the 2 for the shoulder and the 2 from the bicep. So let's take a look at that. On the electrical assembly drawing that he gives you, and again, I'll put a lot of this stuff in as references in my comment section for you to be able to get to. Blow this up a little bit. We'll start here with the left servo card. You can see there's a connector here for the left hand and a connector here for the left arm. So we'll go to the left hand first. It's simple and straightforward. A ribbon cable from there is represented over here by this ribbon cable on this mini breakout board. It plugs in, it's down in the bicep. And that's easy enough, not a real issue, because all the servo cables are long enough to pass out of the hand and into the bicep, or out of the forearm, I should say, and into the bicep. And I extended the wrist and got it to pop through. So everything was looking good. I have those in there, and I'll pick a spot and I'll mount that board. No big deal. Custom fit it wherever it will work for me. So we'll drop that. That was just a little extra. But the left arm assembly, let's study that because that's what we're really involved with right now. That left arm breakout board right here. Left arm. So here's the breakout board. These 2, pins 10 and 11, come over here to the Omniplate and the shoulder, the pivot for the shoulder. They're mounted in the torso. The other pins, 8 and 9, are for the bicep, right? The elbow joint, you might say. And at the top of the bicep, you have the rotate action. They're both mounted in the arm. So you got 2 different assemblies. That one breakout board has got a service. So this is going to be my solution, how I'm going to handle it. You may find a different way to do it. This represents my shoulder assembly, the face where the arm attaches to. Okay, so I have my two ribbon cables, one for the hand and one for the arm. The hand will just pass straight through, we're done with it. But I also bring two servo cables out here. This is the rotate, the pivot rotate of the shoulder, and this is the piston for the Omniplate to raise and lower that shoulder assembly, right? So I brought them out. So now I can slap that arm on and these cables are exposed. In the meantime, this is my arm assembly. This is the top of the bicep. This is the rotate of the arm. This is the rotate right here. Okay. And this coming up through, being fed up through, this is the piston gear for the elbow. It was long enough that I could route it straight up with no difficulty. Now, I made a decision that you may not like, but I didn't think routing these cables is a big deal. They're going to be exposed a little bit no matter what you do. So I took the lazy man approach, and I'm going to bring those cables and I'll hot glue them and do all that proper stuff, and I'm going to route them and I'm going to bring them right through this mounting plate. Now this is where these two pins here, that's where it's going to snap on to the shoulder. And of course it's got its mate over here. Right? So you got the two of them that'll snap on. Well, the front one, which isn't shown, will have the pretty little plate, that says Move Robot. Okay? You can put one on the back as well, which I may do. If I do, I'll simply notch it so that these cables can pass through. And all four of my cables will now be sitting in this cavity where my shoulder and my arm come together. I intend to mount that arm breakout board right in here somewhere. Okay, I don't know for sure where yet, but I'll terminate my ribbon cable here, and then I'll terminate my 4 servo cables here. To me, that was the simplest way to do it. Now, I'm going to take us down a little bit of a rabbit trail here, just a small one. And I'm going to point out, right now I have a temporary screw in here. The reason for this temporary screw is that it's one helping to hold the alignment for my ball bearings. Right? It's the ones that we screw up and down for the tension on the ball bearings. And again, there's no torque ratio or anything given. It's by guess and by golly and how nice, how smooth everything's running. You think it's too tight, loosen them. Too loose, tighten them. It's by gut feel. So I'll have to take that out during my final assembly. Let me back up. I'll get over here where I can back it up. Here you can see the temporary screw here as well, right? I set them backwards. This is the screw that's coming out. so that this assembly, where is it? Well, I screwed that all up. Yeah, this assembly, I'm sorry guys, this assembly goes right here when it's mounted. They'll merge to each other. So I have to take that screw out so that I can put my longer screw through for my ball bearing adjustment on the shoulder. Okay, my mistake. I was saying it was on the arm, but it's on the shoulder, the temporary screw. Does that make sense to everybody? I hope it does. I really don't have a lot more to say. I could try running over here and giving you a live shot, but I've already discovered that it wasn't moving when I was playing with my robot over here when I was demonstrating things for you. My shoulders weren't responding, and the reason was I forgot to turn my power supply on. So I'm not going to try to correct for that. You saw everything live in the video work. I've kind of walked you through the hardest part of routing the cables and how to kind of use my robot lab to do your mechanical electrical alignments and how to pop everything down in place. All right, guys, let's see how this all turned out, and I'll post it later. Again, I'll add some of the stuff to my comments, my reference material. Have a good day, guys. See you later.